All right, guys. Good evening again. We're going to start off with the session now. Uh, so, just a quick, question here. How any of y'all here don't know what the format of a data sufficiency is? Because if all are okay with what a data sufficiency is, I can directly go into addressing what kind of traps the GMAT would test you on data sufficiency, right? So the agenda of the session is this. I'm going to illustrate the most common traps that you're going to find on DS questions, and in the process, right, of elaborating those different traps by using some official GMAT questions, I will also tell you a strategy to avoid falling for these traps. Okay. So the best thing would be to have like a piece of paper at the side. One, obviously for your working, and second, most important, you make a note of what trap that you'll have to check for and how to strategize, right? So that you don't fall for that trap. All right. So it's a mixed bag. Yes, somebody asked me here. It's a mixed bag of questions. It's definitely going to be a mixed bag of questions. It's not going to be only pertaining to one particular topic, right? But I've kept the questions to be slightly, more on the reasoning aspect. It's not going to be test you on your core mathematical skills, right? So I've avoided keeping something like modulus. I've avoided core geometry questions because that would require a bit in-depth knowledge on the concepts. I've kept questions which are solvable even for a person who is starting off with data sufficiency. All right. So guys, we'll kickstart the session, right? I'm going to illustrate each and every trap with an example. The agenda is going to be 2 minutes per question. I want an answer from everybody. I see around 30 and odd people have logged in. I want an answer from everybody, okay? So don't shy away from giving your answer. The purpose of the session is not for me to see how many have got the answers right or wrong. It's for me to illustrate what types of traps you're going to fall for. And remember, whenever you make mistakes, it's always easier to learn from mistakes and not fall for these traps again. Okay, so it's good that you make mistakes because you're going to learn from them. So I'm going to give you the first question. Looks a simple one, but I'm sure you're going to get a slightly different contradictory answers. So here's the first question, and your 2 minutes starts now. Please do not type in the answer in the chat window until I ask you to do so, all right? All right, you can start typing your answers in the chat window. So All right, so I've got a lot of different answers. Majority of y'all have said that delta would be the answer. I've got a couple of echoes and a couple of deltas. I mean, couple of Charlies also, right? So let's actually first discuss this question. Okay, let's work this question out. And in the process of me explaining this question, I'm going to illustrate where you would have possibly made your errors. Okay, and make a note of what mistakes you make, and also make a note towards the side of what you need to take care of on such questions, right? So the question is asking you, is Z even? The first statement is 5Z is even. Now, there are always two ways to solve any data sufficiency, right? One way of working is to use the route of analysis, and the second way of working is to use the route of plugging in values, right? Most of you all would have chosen the plugging in route. Some of you all would have analyzed the question, but let's do it in both ways. Now, the first statement says 5Z is even. So most of you all quickly would have plugged in Z is equal to 2, because if Z is equal to 5Z is going to be 10. 10 is definitely even. And if I take 2 and answer the main question, Z is definitely even here. So you get a definite yes. Now, for those who again plugged in Z is equal to 4, Z is equal to 6, Z is equal to 8, again, you're going to get a continuous string of yeses. But what you fail to do, right? What you fail to do, and this is what you have to be very, very careful of when you solve for data sufficiency questions. You should never try to prove a statement to be sufficient. You'll always have to try to disprove. If you get a yes with one example, try to get a no with another. If it's a value data sufficiency, if you get one definite answer, try to see if there is another answer which is possible. You never try to prove the statement to be true. You always try to disprove. So for those who took Z is equal to 2, Z is equal to 4, Z is equal to 6 and said that the first statement is definitely sufficient, fell for that trap. What you all did is you all made a very, very big assumption that Z is an integer, right? Remember, all they have told me in this question is 5Z is even. I do not know anything about Z, whether it's an integer or not. So Z can be 2, which when I answer with the main question, it gives me a yes. Z can also be a fraction 2 by 5. Because 5 into 2 by 5, the 5 would cancel out, leaving me with Z to be equal to 2, right? Think about it. 5Z is even. If I put Z is equal to 2 by 5, 5 into 2 by 5 is going to be left leaving me with 2, and 2 is definitely an even number. And if I try to answer the main question now, this gives me a no. So the first statement is clearly insufficient, and the three possible answer choices are B, C, and E. Guys, the prerequisite is what the ADBCE technique is, okay? I'm assuming all of you all who have worked with data sufficiency know answer choice alpha stands for statement 1 alone is sufficient, beta stands for statement 2 alone is sufficient, Charlie stands for combine the statements are sufficient, delta stands for individually the statements are sufficient, and echo stands for the two statements individually or together are not sufficient at all, right? So quickly I'm going to write this for people who are new to data sufficiency. These would be the answer choices following every data sufficiency question, okay? Statement 1 alone is sufficient. B, statement 2 alone is sufficient. 1 is not. Charlie, 1 is not, 2 is not. Together they are sufficient. Delta, 1 alone and 2 alone is sufficient. And echo is the statements individually or together are not sufficient at all. So when I say that the first statement is insufficient, I'm going to look at the crosses on 1. So the crosses on 1 are on B, C, and E, right? So the three possible answer choices are B, C, and E. If the first statement was sufficient, then the two possible answer choices here are going to be AD, right? So we use something called the ADBCE technique to solve any data sufficiency question. So the take back here from the first statement is, first, you never assume that all values that you're working with are integer values. You always check for all types of values. So as a rule of thumb, what I do is I always check for values based on this acronym called ZONEF. Z stands for 0, O stands for 1, N stands for negative, E stands for extremes, and F stands for fractions. I always plug in values based on this acronym. I always think of using 0 and 1 first. Then I think of plugging in negatives. Then I think of plugging in fractions, right? I use extreme values also, that will come towards later, right? So whenever you're plugging in values, don't assume that all values that you plug in are only going to be integer values. And second, make sure you try to disprove the statements, not try to prove the statements to be sufficient, right? So the first statement clearly is insufficient. Now coming to the second statement. The second statement says 3z is even. So clearly now if I put z is equal to 2, 3z would be even. And if I answer the main question, this gives me a definite yes. But again, I'm going to try to disprove. So I'm going to put z is equal to 2 by 3. 3 into 2 by 3 still gives me 2, which is even. But if I answer the main question, 2 by 3 is not an even number. So I get a yes and a no. The second statement is also insufficient. I can cancel out B. Now I need to combine the two statements, right? When I need to combine the information between the two statements, now this is your third take back. When you need to combine information between two statements, you never try to continue with the process of plugging in values, or you never try to go the route of an analysis. The best thing to do when you're plugging in, when you're combining two statements, is to always try to use one statement, right? Always try to substitute the information given in one statement into the other, or use a mathematical operation or a set of operations between the two statements, which leads to answering the main question, right? I've been given 5z is even. I've also been told that 3z is even. Now what I'm going to do, instead of plugging in values, I'm going to use a mathematical operation, and I need to be smart with the operation here, such that when I manipulate both these statements together, I need to get information about z. So the best thing to do here is to multiply the second statement by 2 on both sides. So if 3z is even, 2 into 3z is 6z, and even into 2 will always be even. So I know 6z will also be even. So the second statement I manipulated to be 6z is even now, and the first statement gives me 5z is even. Now if I subtract these two values, 6z minus 5z gives me z, and even minus even gives me an even value. So I know when I combine the two statements, I'm going to get z definitely to be even. So the answer here should be Charlie. I'm going to repeat. What I did when I combined the two statements is I used a mathematical operation or a set of operations between the two statements, which always led to answering my main question. So what I did is I multiplied the second equation by 2 on both sides. If 3z is even, 6z would also be even. And then I subtracted 6z with 5z, which is even minus even. So gives me z to be even, right? So there's a lot of take back on this question. See, I'm not going to use the LCM because I need to deal with fractions also, right? You need to understand it, right? It's going to be very hard for me to take LCM of those two numbers and then work with it. The risk you run if you use values is that you'll be left with an inkling of doubt in your head, saying that there might be some value, some large value which might prove this to be sufficient or insufficient. Okay, that's the big risk. Yes, you can definitely say 15z is even if you want to multiply the two also, right? But if you multiply the two, you don't get 15z, you get 15z square is even, right? So keep that in mind. Perfect. See, you could have also added the two statements here. Why didn't I choose addition? Because when I add the two statements here, I'm going to get information about 8z. See, I don't want information about 8z, right? I want information about z. On a data sufficiency, your working procedure should always be towards what the question asks you to find out, okay? Not anything else. You should be like a horse with blinkers, right? You should only look at the end goal in mind, and the end goal is about getting the information about z, not about anything else. All right, so I'm going to repeat. First, when you're plugging in values, always make sure to use all types of values. Don't assume that everything is going to be integers. Second, whenever you approach any data sufficiency statement, always try to disprove the statement, Never try to prove. Always try to think negatively on a data sufficiency. Third, when you're combining statements, right? Never try to use a number or never try to analyze it, right? Always try to use one statement into the other or try to perform some mathematical operation between the two statements, which leads to answering, most importantly, the main question. Okay? You can manipulate the statements the way you want as long as you don't go against what the statements specify. Okay with this, guys? All of you all? Everybody? Perfect. So we're going to move on to the next question. Here's your next question. And your time starts now. All right, you can start typing your answers in the chat window. All right, last 10 seconds, guys, for an answer. Okay. So I've got a lot of C's. I've got some amount of A's. I've also got a couple of D's. I've also got a couple of B's, right? Now, again, see, for every data sufficiency question, right, there are a lot of takebacks, right? I gave you like 3 to 4 takebacks on the first question. Again, you can learn a lot from the second question, okay? Now, the first thing that you have to be very, 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 very careful about is you never treat a data sufficiency as something that can be solved in 5 seconds. Okay, you never look at the first statement here and you say first statement gives me prices of 2 items, doesn't give me the third, insufficient. The second gives me the price of the third item, doesn't give me the first two, insufficient. So obviously combined they have to be sufficient. That's a very, very, very bad way of solving a data sufficiency, right? When you look at a question and you see that it's very obvious that the two statements combined are sufficient to solve a question, you have to be always aware of something called the classic C trap, right? Any answer that comes in 5 seconds is something that you'll always have to revisit. All right. So this is what we call a classic C trap, when both statements together look that they should be sufficient to solve, right? So whenever we see a question of this form, it's always better to take a step back and always analyze the two statements individually first. Okay. And remember what I told you, take back what I told you from the first statement. On a data sufficiency question, the only way you can discard a statement is you always try to disprove the statement. When do you discard a statement? When you get a case, a contradictory case, right? In terms of a yes no data sufficiency, you get a yes and a no, and for a value data sufficiency, you get contradictory answers, right? Now, clearly looking at this question, the question was the total amount of the three discounts greater than 15% the sum of the regular prices of the three items? This data sufficiency is a yes-no data sufficiency. So the only way you can eliminate a statement by saying it's insufficient is if you get a contradiction in terms of a yes and a no. Now, there are multiple ways to work this out. Some of you all would have directly taken values and work with it, and then use numbers and try to figure it out. Some of you all would have just looked at the two statements, said both together needs to be sufficient. So C. First thing, beware of the classic C trap. Second, always, again I'm repeating, try to disprove the statements. Third, whenever you get word problems like this, right? According to me, the word problems are the toughest aspect of the GMAT because they make it very, very tricky, especially in data sufficiency. Whenever you get word problems, the best thing to do is to, instead of jumping to the statements, always learn to break down the question. Okay? Translate all these wordy information into algebraic equations and then try to solve. Okay? So see how I'm going to break this down into algebraic equations. And after I break this down into algebraic equations, I'm going to target the statements. Henry purchased 3 items during a sale. So let me keep the regular prices of the 3 items to be X, Y, and Z. He received a 20% discount on the price of the most expensive item. So I'm keeping X to be the most expensive. And a 10% discount of the regular prices of the other 2 items. So 10% here, 10% here. And the question is asking me, was the total amount of the 3 discounts greater than 15%, the sum of the regular prices of the 3 items? So I'm going to break this down. Now the total discount here is going to be 20 by 100x plus 10 by 100y plus 10 by 100z. So this is the total discount. Now the question is asking me, was the total amount of the 3 discounts greater than 15% the sum of the regular prices of the 3 items? So the regular prices of the 3 items are X, Y, and Z. So X plus Y plus Z. So I've broken this entire statements down into an algebraic equation. Now I'm going to simplify further, right? Don't stop at this point. Simplify further. I can remove the 100 throughout. I have 20x plus 10y plus 10z is greater than 15x plus 15y plus 15z. I'm going to take all the x's to one side and the y and z to one side. So 20x minus 15x is greater than 15y plus 15z minus 10y minus 10z. So 5x is greater than 5y plus 5z. I can divide throughout by 5. So now this entire question boils down to, is x greater than y plus z? So the question is just asking me, is the regular price of the most expensive item greater than the sum of the regular prices of the next 2 items, right? I've broken down this entire percentage question to just a data sufficiency in terms of X, Y, and Z. Now I'm going to look at the statements. The first statement says that the regular price of the most expensive item was $50. So X is equal to $50. And the regular price of the next most expensive item was $20. So Y is $20. And remember, I know the first statement doesn't give me Z, but Z has to be the least expensive item. And if Z has to qualify as the least expensive item, it has to be either equal to 20 or lesser than 20, right? So looking at the first statement, remember I need to answer the main question. Looking at the first statement tells me X is 50. This is always going to be greater than Y plus Z because Y is fixed to be 20 and Z is going to be a value which is less than 20. So the left hand side will always be greater than the right hand side. I get a definite yes. So the first statement is clearly sufficient. And the two possible answer choices are AD. Now looking at the second statement. The second statement says the regular price of the least expensive item was $15. So all I have is Z is equal to $15. I don't have any information about X and Y. Or I can just plug in quickly. X can be 16 or X can be 17. Y can be 16. Z can be 15. In this case, X will be less than Y plus Z. Or I can take X to be 100, Y to be 16, Z to be 15. In this case, X is greater than Y plus Z. So I get a yes and a no for the second statement, which makes it insufficient. So the only possible answer choice here is alpha. So there are three things that you have to take back here. One, whenever you see a question where you see the two statements together are sufficient to solve, it's always better to take a step back, understand that it might be a classic C trap, and work with the statements individually. Second, and I'm going to repeat this throughout this entire webinar, you never try to prove the statement to be sufficient. You always try to disprove. You always try to contradict, right? Whatever initial answer the first statement gives you. Third, whenever you have word problems, it always makes sense to break down the question using algebra and then break down or rephrase the data sufficiency to a much simpler form. Once you do that, the analysis of the statements are going to become much easier. Okay with this, guys? All of y'all? Because Z has to be less than 50, Shikhar, because the statement itself tells me, right, the regular price of the most expensive item and the regular price of the next most expensive item, right? Just use logic, isn't it? If regular price of the most expensive is 50, regular price of the next most expensive is 20, then the least expensive has to be less than 20, right? Right? It's just logic, isn't it? It's based on the first statement itself. Okay with this, guys? Okay with this? I'm hoping you're noting down the take back that I'm giving you for each question, because that's more important than solving the question. Okay. You understood the advantage of breaking down the question and making and rephrasing the data sufficiency. You see how easy it becomes? And this is especially for people who got the answer but used the route of plugging in values. All right. Perfect. So can we move on to the next question? All of y'all? What do you want for me to explain in the last two lines, Sanjana? I've just manipulated algebraically, right? I've just taken all the x's to one side, y to one side, and then, simplified the equation into a lower form. That's all. You I canceled the 100 on all sides because 100 is a positive value for those who know, right? So 50 is greater than y plus z, right? So the question just asks me whether the most expensive item is greater than the regular price of the sum of the least expensive and the next most expensive, right? Perfect. Okay, so here's your next question, guys. Again. So again, I'm repeating myself. Never try to prove the statement to be sufficient. Always try to disprove. Second, don't jump into the statements. Analyze the question, break it down into a mathematical equation, see what is sufficient, see what is not, then go to the statements. Your 2 minutes starts now. Okay, guys, you can start typing your answers in the chat window. Last 30 seconds. Last call for answers, guys. Quickly type in whatever you've got in the chat window. It's absolutely fine, right? I told you that the purpose of the session is what is the take back from what mistakes you make. Okay, I want you to make mistakes because that's the best way you can learn. Perfect. So most of y'all, and I'm impressed with this. Most of y'all have taken on board what I told you in the last two questions, right? And have applied it here. And most of y'all have given me the correct answer, which is B, right? Some of y'all have still not taken on board what I said in the previous question and marked C, right? I have a couple of A's and a couple of D's also. But let's actually work this out, right? I'm not going to go into the statements. I'm only first going to look at the question stem. In a certain year, the difference between Mary's and Jim's annual salaries was twice the difference between Mary's and Kate's annual salaries. If Mary's annual salary was the highest of the three people. So I know what the question tells me is the difference between Mary's and Jim's annual salary, that's M minus J, was twice the difference between Mary's and Kate's annual salary. So twice the difference between Mary and Kate's annual salary. So this is given to me in terms of equations. Why did I take M minus J and M minus K, not J minus M and K minus M? Because the next line tells me, right, that Mary's annual salary was the highest of the three people, right? So I need to, from the highest value, subtract the other value, right? And what is the question asking me? The question asking me, what is the average annual salary of the three people that year? So the average annual salary is going to be M plus J plus K divided by 3. That would be the average, right? And this is what I need to find out. So I'm still not going into the statements. I'm still working with my question here. I have M minus J. So I'm going to break this down. M minus J is equal to 2M minus 2K. I'm going to take the M's to one side. So I'm going to get 2K minus J is equal to 2M minus M, which is M. So M is actually 2K minus J. And the question is asking me M plus J plus K divided by 3. So it's asking me the value of M plus J plus K divided by 3, right? So I can write M plus J, taking the J to the right-hand side. I can replace M plus J as 2K because that's what the question gives me. So this becomes 2K plus K divided by 3. That would be the average. And 2K plus K is 3K. And 3K divided by 3 would be K. Right? So the average here of this entire question, M plus J plus K divided by 3, based on the information given, is just K. So if I have information about K, I can easily find out what the average is going to be. The first statement gives me Jim's annual salary was 30,000 that year. So what I've got in the first statement is J is 30,000. Remember, I need the value of K. I have J, insufficient, BCE. Second, Kate's annual salary was 40,000. That's exactly what I want because the average salary here is given by K. The second statement, clearly sufficient, right? So again, for those who fell for the classic C trap again by saying Jim and Kate's salary both are required, then you made a mistake. You didn't work with the statements individually, right? And remember, right? Remember, whenever you have word problems, always make sure you break down the question step, right? All that was given to me was this equation: m minus j is equal to 2m minus 2k. Breaking that down, I got 2k minus j is equal to m. So 2k has to be equal to m plus j. And the question asked me to find out the value of m plus j plus k divided by 3. So if m plus j plus k divided by 3 is the average, I can replace m plus j as 2k. So this term becomes 2k. So the average becomes 2k plus k divided by 3. So the average would be 3k by 3. 3 and 3 can cancel out. So the average of this entire set of terms would just be k. So if I find out the value of k, I can clearly find out what the average is going to be, right? You'll have to be very, 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 very careful on data sufficiencies because you'll need to know how to break down the question. If you break down questions, work your way algebraically in the beginning, right? That's going to serve really, really good, especially when you work with the statements individually. Okay with this, guys? Everybody? Okay with how I broke it down? No, you can't take mod, Shikhar. You cannot take mod here, okay? I can have a difference, isn't it? I can have m minus j to be twice in terms of negatives also, right? That's why they've clearly mentioned that m is greater because they don't want the negative condition. So you can't take mods just like that, all right? If it is not mentioned, you just can't take mods. You'll have two cases. You'll have m minus j or j minus m. You cannot take the mod. Okay with this, guys? Any other doubts? Perfect. Okay with the points so far? I'm hoping all of you all are making note of how to proceed with questions, right? Okay. So here's your next question. It's a good one, a tough one. I would definitely classify this as a good 700 level question. Your time starts now. All right, guys, you can start typing your answers in the chat window. Another 30 seconds. Last call for answers. All right. Now, this is definitely what I would say would be a 700 level question on the GMAT, right? You'll realize that the higher levels of questions will not be too problematic in a mathematical sense. They'll be problematic in an analysis sense, okay? So most of y'all are still not taking back what I told you in the first 3 questions, and I'm going to repeat this again, okay? The only way, and what I would want you to develop your mindset to do, the only way you discard a statement is if you get a contradiction. You always try to disprove. When do you discard the first statement? Only when you get a yes or a no, right? Or only if you get, a definite answer, or you get multiple possibilities instead of getting a definite answer. The only way you can discard a statement is if you get a contradiction. Otherwise, you don't discard a statement. And second, again, I'm repeating from what we discussed before, you always work towards what the question asks you on a data sufficiency. Okay? And taking back what we did in the last 2 questions, it's a word problem. So you need to break down the word problem into an equation form. Okay? Now, the question says Yamiko drove from point A to point B at a constant speed and then returned to A along the same route at a different constant speed. Did Yamiko travel from A to B at a speed that is greater than 40 miles per hour? So let me keep the speed from A to B as SAB, and let me keep the speed from B to A as SBA. Now the question is asking me, is SAB greater than 40? That is what the question is asking me here, right? Now here again, you'll have to include on the harder levels of questions, you'll have to know some concepts of speed, distance, time, right? For those who know the concept of speed, distance, and time, if distance is constant, or if you have like a round trip, right? How do you calculate the average speed? Anybody? If the speed from A to B is SAB and the speed from B to A is SBA, if it's a round trip, what would be the average speed of the entire journey? Anybody? Perfect. The average speed is always 2AB divided by A plus B, right? It's total distance by total time. But since distance is constant, right? It's always going to be 2AB divided by A plus B. So in this case, the average speed is going to be 2 SAB into SBA divided by SAB plus SBA. And the first statement gives me that Yamiko's average speed for the entire round trip, excluding the time she spent at point B, was 80 miles per hour. So the average speed, that's 80, is actually 2AB by A plus B, right? That's 2 SAB into SBA divided by SAB plus SBA. So this is what the first statement gives me. 2 ones are 2 40s are. So I'm going to say 40 into SAB plus SBA is equal to SAB into SBA. Now, for most of you all who have done this and just directly discarded the statement, then you did not take back what I told you in terms of disproving a statement rather than proving it. You never eliminate a statement to be insufficient, saying that SAB is not given, SBA is not given, so I can't say whether it's greater than 40 or less than 40, right? You have to try to always get a contradiction. And what is the question asking you to find here? This question is asking you to find out whether SAB is greater than 40. So I'm going to manipulate my equation such that I make SAB the subject. So I'm going to divide throughout by SBA here. So SAB, I'm going to take this SBA down here, is going to be 40 into SAB plus SBA divided by SBA. You see how I'm making SAB the subject here, because that's what the question is asking me to find out. So this gives me SAB is equal to 40. I'm going to break this fraction down into two different fractions. So SAB divided by SBA plus SBA divided by SBA gives me 1. Right? I'm just splitting this fraction up. So what does SAB give me? SAB gives me something which is 40 into SAB by SBA plus 1. Now SAB by SBA can be a fraction, it can be any integer. But to that fraction or integer, if I add 1 and then multiply that entire sum to 40, I will always get SAB to be greater than 40. I will never be able to disprove that the first statement is insufficient. So the first statement here is clearly sufficient, and the two possible answer choices are AD. Okay with this, guys? Okay with how I manipulated this? See, the point I want you to hold on to here is, one, get into the habit of always trying to disprove. Never discard statements just because they have two variables and the two variables can't be solved. You should always work towards what the question asks you. Okay? You should have like a very structured approach while solving a data sufficiency. Otherwise, you're going to fall for a lot of traps. Work towards the question. Always try to disprove the statement. Don't discard a statement just because it seems insufficient to you. Okay with how I broke this down, and okay how I made SAB the subject and then proved it to be greater than 40, all of y'all? Perfect. Now what about the second statement? Now in this entire question, right, they are telling me that Yamiko drove from point A to point B and then returned to A along the same route, right? So I know that clearly distance is going to be constant. So when distance is constant, right, I know that SAB into TAB has to be equal to SBA into TBA. Because since distance is constant, the distance from A to B has to be equal to the distance from B to A. And the distance from A to B will be equal to speed into time. So speed of A to B into time of A to B. And the distance of B to A again will be speed into time. That is speed of B to A into time of B to A. And what the second statement tells me is, it took Yamiko 20 more minutes to drive from A to B than to make a return trip. So it took Yamiko 20 more minutes to drive from A to B than to make a return trip. So the second statement tells me SAB is actually SBA plus 20 minutes. So that's 20 by 60, right? So the second statement tells me SAB is equal to SBA plus 1 by 3. Now I need to solve for, remember, SAB, and I need to figure out whether SAB is greater than 40 or not. So this gives me SAB is equal to SBA into TBA divided by TAB, right? This is time, not speed, time, right? So if the time from A to B is time of B to A plus 1 by 3, I have SAB is equal to SBA into TBA divided by TAB is TBA plus 1 by 3. Now looking at this equation, and by quickly putting in some values for SBA and TBA, you can easily prove that entire value to be greater than 40 or less than 40. For example, if I put SBA as 40 and I put TBA as 2, right? I'm putting SBA as 40 and TBA as 2. I'm going to get 40 into 2 is 80, and 2 plus 1 by 3 is going to be 5 by 3, right? So this is going to be into 3. 5 8s are 40, 8 3s are 24. 24 into 2 gives you 48. But I can take SBA also to be 1 and TBA to be 2. So clearly I can figure out, since I can manipulate the terms for SBA and for TBA, I know that SAB can be either greater than 40 or less than 40, since it depends upon the value of SBA. So clearly the second statement is insufficient. The answer here is alpha. Okay. So you have to be very, very, very structured on a data sufficiency, right? You should never discard a statement just because, two variables are given and I'm not able to solve for these variables, right? You always try to prove them to be sufficient or not, right? It's always better to try to disprove the statements by getting a contradiction. Okay with this, guys, all of you all? So you'll realize how the 711 questions are going to be here, right? Going to be slightly more trickier. Which statement do you want to explain, Abhishek? So what I did, Abhishek, in statement B is I just let me clear the screen so that I can work with it on a clean slide. Okay. See what I say in the second statement is, in the second statement I clearly have this piece of information, right? I have that distance is constant. So the distance of A to B has to be equal to the distance from B to A. The distance of A to B will be the speed from A to B into the time from A to B, and the speed from B to A into the time from B to A. And the second statement tells me that the time that you take from A to B is 20 more minutes than the time you took from B to A. That's 20 by 60, which is 1 by 3. Right? Now, remember I need to solve for SAB. So SAB is equal to SBA into TBA divided by TAB. SBA, I'm going to keep it as it is. TBA, I'm going to keep it as it is. TAB, I'm going to write it as TBA plus 1 by 3. Right? Now, I'm just going to plug in values. If I plug in SBA as 1, TBA as 1, 1 into 1 divided by 1 plus 1 by 3. 1 plus 1 by 3 is 4 by 3. The 3 goes on top, gives me SAB to be 3/4. Now 3/4 is definitely less than 40. This gives me a no. If I put SBA as 40 and TBA to be 2, 40 into 2 divided by 2 plus 1 by 3. 2 plus 1 by 3 is 5 by 3. So 40 into 2 into 3 divided by 5. 5 8 is a 40, 8 2 is a 16, 16 3 is a 48. This gives me a value greater than 40. It gives me a yes. So the second statement clearly is insufficient, right? So I'm not just discarding it just because it has two variables and I can't solve for it, okay? I'm actually putting in values and getting that contradiction. That's what you need to always do. Never eliminate a statement just because it has two variables and one equation. Perfect. So can you move on to the next question, all of you all? Okay. So here's the next question. Your 2 minutes start now. All right, you can start typing your answers in the chat window. Looks an easy one. Lots of take back from this question. Another 10 seconds, guys. It's not a very tough one, but there's a big point that I want to illustrate here. All right. So most of y'all most of y'all, I think almost, I would say 90%, no, 95% of y'all have given me the answer to be B for Bravo. So let's work this out, okay? And most of y'all gave me a quick B for Bravo because you realize that this question would be absolutely problematic if you plugged in values, right? Now, x to the power of 7, y square, z cube is greater than 0. That's the question. So all of y'all did the good bit. Y'all analyzed the question first, okay? So that I'm going to give you credit for. Y'all said, and this is what you would have done in your head, y square is positive. So if I need this entire product to be positive, x and z, the product of sz also has to be positive. And if xz has to be positive, they both have to be of the same sign. And when you looked at the two statements, only the second statement gave you x and z to be the same sign. And then many of you all picked B. A very, 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 very nice and intricate trap on data sufficiencies or in any type, even in the problem solving question, is overlooking 0. All of y'all who gave xz, the second statement, to be sufficient, assumed that y square has to always be positive. But y square can be 0 or positive. Remember, even exponent is not positive. An even exponent is always non-negative. That would be a better way of representation. Yes? So never, 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 never make an assumption that any even exponent is always going to be positive. And nowhere have they given me any information about x, y, and z, right? So I have y to be 0, I have y to be positive, I also have y to be negative. So when I look at the first statement tells me yz is greater than 0. Clearly, I know that y can be positive or negative here, so y square will always be positive. Z cube can be either positive or negative, but I have absolutely no clue about x. So the first statement is insufficient. The second statement gives me xz is greater than 0. So I have x to be positive, z to be positive, or x to be negative, z to be negative. If I take y to be positive, y square will also be positive. This gives me a yes. If I take y to be negative, y square will be a positive, xz will also be positive. This also gives me a yes. Again, your approach should be trying to disprove. Right? I'm just taking any two cases for x and z. If I take y to be 0, then the product of x to the power of 7, y square z cube will be equal to 0. And if it's equal to 0, is 0 greater than 0? I get a definite no. So I get a contradiction in terms of a yes and a no. The second statement is insufficient. Now, when I combine the two statements, I have definite information to say that y can only be positive or negative, because to satisfy the first statement, y has to only be positive or negative. So the case of y being 0 is ruled out. So if y being 0 is ruled out, y square now will always be positive. And the second statement gives me that x and z have to be the same sign. So x to the power of n z cube will also be the same sign, which gives me the product to be greater than 0. So the answer here has to be Charlie. Okay with this, guys? So one big trap is never, ever overlook 0. You remember in the beginning, I told you that I follow this acronym called ZONEF, and I said Z stands for 0, O stands for 1, N stands for negatives. There are two reasons why I think about 0 in the beginning. One, because it is easy calculation. And the second is because there's always traps associated with 0. See, the first statement is clearly insufficient, right? Yz is greater than 0 just tells me y is positive, z is positive, or y is negative, z is negative, right? I don't know anything about x. X can be positive, x can be negative, x can also be 0. So if I don't know the value of x, I don't know what sign x to the power of 7 would take, isn't it? So clearly I can discard the first statement. The second statement just tells me x and z are of the same sign. I can't assume that y square is always going to be positive, right? So the 0 case is going to disprove the second statement entirely. See, Santosha, ZONEF is just like a, acronym to plug in values in a very structured approach, right? Z always stands for 0, O stands for 1, N stands for negative values, E stands for extreme values, and F stands for fractions, right? It's always better for you to plug in values in this acronym because one, 0 and 1 is easy calculation, and second, by plugging in and checking for 0 first, no, you cut out all the traps associated with 0. Okay? And always you make sure that you check for all types of values also. That's the purpose of using that acronym, all right? Okay, guys, can we move on to the next question? All of y'all? Right? Be a little careful when you read the next question. Here's your next question. Your 2 minutes starts now. You can start typing your answers in the chat window. Guys, think your way through. Okay, don't directly say that combined sufficient. Think your way through the question. All right, don't be hasty. Another 30 seconds. Last call for answers. I see a couple of you all have changed your answers now. All right. Perfect. So I see a lot of C's. I see a couple of E's, and I also have a couple of D's, right? Again, I told you, right? Whatever you learn in the previous questions, it's always better for you to take back something from that question. So the question is x square plus y square greater than 4a? The first statement says x plus y whole square is equal to 9a. Now I'm going to open the brackets up here. So x square plus y square plus 2xy is equal to 9a. Now the question is asking me whether x square plus y square is greater than 4a, right? So I can just say that x square plus y square is equal to 9a minus 2xy. Now I don't know whether 9a minus 2xy is going to be greater than 4a or not, right? For that, I'll need to know information about a, x, and y. So clearly the first statement is insufficient. It's very easy to eliminate the first statement. The second statement tells me x minus y whole square is equal to a. So x square plus y square minus 2xy is equal to a. So x square plus y square is equal to a plus 2xy. Again, I don't know whether a plus 2xy is going to be greater than 4a or not, right? For that, again, I would need information about what values a takes and x and y takes. So out goes b. So it's very, very easy for me to eliminate the statements individually, okay? So what am I going to do when I'm going to combine the two statements? Like I said in the first question, when you combine two statements, always try to work towards the question. And you remember, you can use mathematical operations between the two. So the first statement tells me x plus y whole square, sorry, x square plus y square is equal to 9a minus 2xy. And x square plus y square is also equal to a plus 2xy. So clearly I can add the two here because 2xy would cancel. So I have 2x square plus 2y square is equal to 10a, or x square plus y square is equal to 5a. So if x square plus y square is equal to 5a, the question now becomes, is 5a greater than 4a? And most of y'all, just by looking at this, you'll have said that this is sufficient. The reason you've said that this is sufficient is because you've considered a to be positive. 5a will always be greater than 4a only if a is positive, but a can also be 0 here, right? If I put a to be 0, think about it. X to be 0, y to be 0, a to be 0, it's still going to satisfy the combined statements because x square plus y square will still be equal to 5a. And if x is 0, y is 0, and a is 0, if I take that and answer the main question, x is 0, y is 0, a is 0. That gives me 0 greater than 0. Now 0 can't be greater than 0, right? So this gives me a no. This gives me the contradiction. Any other positive value, if I substitute for x, y, and a, it's always going to give me x square plus y square is greater than 5a because x square plus y square will give me 5a. But if I substitute a as 0, then all of this statement, this entire statement is going to be disproved. So the answer here is going to be echo. Right? Again, most of y'all forgot the case of 0. You can't take square root, right? I mean, how can you take square root of x square plus y square, Shikhar? I mean, you're telling me that x square plus 9, this is 9, root of x square plus y square is x plus y, is it? Root of x plus y whole square is x plus y, isn't it? Not root of x square plus y square is x plus y, right? That's not right. I can't take a to be negative, Sanjana, because if x square plus y square is equal to 5a, right? Think about this. A square will either be 0 or positive. So this x square will always be 0 or positive. Y square will always be 0 or positive. Two numbers which can be 0 or positive added to each other cannot give me a to be negative, right? You can't take, yeah, in statement 1, you can take square root, Shikhar, no problem. That's absolutely fine, right? That's absolutely fine. But whenever you solve for questions, right, and especially with squares and things, you need to understand that a square and a square root is not the same. No. So root of 9a is not plus or minus 3a. This is completely wrong. I think you have to revisit your concepts of algebra. Root of any constant, a is a constant here. Keep that in mind. X, y, and a are real. Root of any constant will always be positive. Root 49 is 7. Root 25 is 5, right? So you can't do that. All right. So guys, the really big trap here is you always have to take care of is never forget 0, okay? You'll need to think about 0 always first whenever you go the route of analysis or plugging in values, right? Normally people overlook 0 and get to the answer. You have to be very careful about 0. Okay with this, can we move on to the next question? Perfect. So here's the next question. Your 2 minutes start now. Again, I would classify this as a good high 720, 730 level question. All right, you can start typing your answers in the chat window. Guys, remember that this for a value data sufficiency, right? What is sufficient is when you get a definite answer, right? If you get like an answer, if the question is what is the value of X and you get X is equal to Y, that's not a definite answer. Okay. Got it? So you need to realize that if I get what is the value for X and get X is equal to Y, X will depend upon the value of Y and Y can take whatever value I want, isn't it? So in a value data sufficiency, you need a definite answer in terms of a definite number. Last call for answers. All right. So this is a very, 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 very good question. And it just illustrates, one point that whenever you look at a question, right, the obvious answer may not be the answer at all, right? Obviously, for people to look at this question and realize that the question is asking me the value of Z and the value of Z needs to be a definite number. And all I've got in the two statements is all variables equated to each other. So I will not be able to find a definite value only with variables. So clearly the answer here should be echo, right? Now, what did you do for those who did this and got echo? Then again, you went against what, how you need to solve a data sufficiency. You'll always have to work with the statements individually, try to break down the question as, move on, and then always look for a contradiction, right? Now, what is given to me here is if x minus q is equal to s minus y. So I can rephrase this as x plus y is equal to s plus q. Now think about this, okay? If I give you x plus y, that is two angles, the sum of two angles in a triangle, that is equal to s plus q, the sum of the other two angles in another triangle, then if two angles, the sum of two angles are equal in the two triangles, then obviously the third angle is also going to be equal. So the hidden piece of information that I've given here is z is equal to r, right? The statement itself gives me this information. If you want me to prove it, I have x plus y plus z is equal to 180 and I have s plus q plus r is equal to 180, right? I'm going to subtract the two. I know x plus y is equal to s plus q, so this would cancel. Z minus r will give me 180 minus 180, which is 0. So z obviously has to be equal to r. So from the statement itself, I have z is equal to r, right? So I have x plus y is equal to s plus q and z is equal to r given to me in this question stem itself. And the question is asking me to find the value of z. Now, why is this a hard question? Is because if we didn't do the z is equal to r, then you're going to definitely pick either Charlie to be the answer or echo to be the answer. Now let's work with the first statement. The first statement says xq plus sy plus sx plus yq is equal to zr. Now, normally what we would do when we see terms like this is to group the terms and take things common, right? So I'm going to take x common out of these two, so x into s plus q. I'm going to take y common out of these two, so that's y into s plus q is equal to zr. So out of these two terms, I can take x plus q common. I'm left out with x plus y is equal to zr. I'm breaking the statement down. I have x plus y is equal to s plus q given to me in the question stem. So I can replace this as x plus y whole square. I have z is equal to r given to me in the question stem. So I can replace r by z and I'm going to get z square. Now, why didn't I replace z by r and get r square? Because the question is asking me for z, right? So I'm always looking to work towards the question. So I can just square both sides, square root both sides and say x plus y is equal to z, right? I can't have negative values for x, y, and z here. So because they are angles at the end of the day. So the first statement tells me that x plus y is equal to z. Now think about this, okay? In a triangle, you have the three angles to be x, y, and z. If I tell you that x plus y has to be equal to z, then the only way I can have the triangle to satisfy this condition is if z is equal to 90 degrees. I'll prove it to you again. I know x plus y plus z is equal to 180 because it's the sum of all interior angles in a triangle. X plus y is z, so z plus z is 180. That gives me 2z is 180, which gives me z is equal to 90. So the first statement is clearly sufficient and the two possible answer choices are AD. Second, zq minus ry is equal to rx minus zs. Again, I'm going to group the terms. Zq plus zs is equal to rx plus ry. I take z common, s plus q. I take r common, x plus y. I have s plus q is equal to x plus y. So this I can cancel out. I just get z is equal to r. Remember, I already know what this information is. I already know that z is equal to r from the question stem itself, right? I can't find out the value of z here just by z is equal to r. Basically, what this gives me is 1 is equal to 1. And I can't do anything with this statement 1 is equal to 1. It doesn't make sense, right, to work the main question with this, right? So the second statement is clearly insufficient. And the answer here has to be alpha. Okay with this, guys? The obvious may not be so, right? You can assume that I'm dealing only with variables here, so I'm definitely going to get echo as the answer. But I told you, never discard the statements, right? Work your way through. Always solve for what the question asks you to find. Okay with this, guys? All of y'all? You understand why this is a very, very hard question? It's hard, but what concept is it actually testing you on? The only concept that this question tests you on is just that the sum of all angles in a triangle is 180 degrees. That's the only concept that this question tests you on, nothing else. Okay with this, guys? Can we move on to the next question? Perfect. It will continue up till around 9:15, Sanjana. Okay, I have another 3-4 questions left. This is the last question, and then we're going to move into a couple of challenger questions. Okay. So guys, again, remember what I said. The obvious may not be so. Hold on to what we discussed in the previous questions. Remember all of that while working the question in front of you, right? Don't make any assumptions. Don't assume the obvious to be the answer, and always work your way through the statements, right? And always try to get a contradiction. Your 2 minutes start now. All right, you can start typing your answer in the chat window. Last 10 seconds. All right. So clearly, some of you all identified that this question tests you on your understanding of a Venn diagram, right? So the question says, I'm going to break down the question first. A gated community consists of 55 people, has 3 fitness clubs, A, B, and C. So I'm going to represent each of the fitness clubs with a circle. So this is A, this is B, this is C. Of the 55 residents, 40 residents are members of exactly one of the 3 fitness clubs in the complex. So the regions which represent exactly one is going to be this region, and this region. So I'm going to call this X, I'm going to call this Y, and I'm going to call this Z. So what I've been given is X plus Y plus Z has to be equal to 40. And the question is asking me, are any of the 55 residents members of both fitness club A and C, but not B? Right? So the region which represents A and C, but not B is this region here. And the question is asking me, does that region include any people or not? Or is that region a value greater than or equal to 0? Right? I've broken down the question. I need to figure out this region A. Now, the first statement tells me 2 of the 55 residents are members of all 3 of the fitness clubs in the apartment complex. Now, before I go into it, one big take back I told you is never make any assumptions on any data sufficiency question. So for most of y'all who gave me Charlie to be the answer, what you assumed was that all 55 residents have to be a part of fitness club A, B, and C. Y'all didn't bother about the fact that there could have been some people out of the 55 who need not be parts of fitness club A, B, or C. So you can't assume that the outer region is 0, because nowhere in the question have they mentioned that all 55 people have to be a part of fitness club A, B, and C, right? You can have some which are not. So the outer region D is the most important here. If you overlook that and you make an assumption, the answer would definitely be C, and you would fall for the trap answer. So the first statement tells me that 2 of the 55 residents are members of all 3 fitness clubs in the apartment complex. So this intersection region is 2. I already have X plus Y plus Z to be 40. So 40 plus 2 gives me 42. So 42 residents are already considered in the circle. I have a total of 55 residents. So 55 minus 42 is 13. So I still have to distribute 13 residents, right? So I can do it the way I want. I can put 13 in this value for A. I can put this is 0, this is 0, and the outer region to be 0. Or I can flip it 0, 0, 0, 13. So this region can have some people, need not also have some people. So the first statement is clearly insufficient. Now let's take the second statement. 8 of the 55 residents, please don't carry over the information from the first to the second. Okay, some of you all answered B, so I'm assuming you answered B because you carried over the information. Remember, look at the statements individually first. 8 of the 55 residents are members of fitness club B and exactly one other fitness club in the apartment complex. So B and exactly one other means B and only A, that would be this region, and B and C but not A, right? That would be this region. So I've been given this region plus this region to be a total of 8 residents. So now I have X plus Y plus Z to be equal to 40. I have this region, the shaded regions, to be a total of 8. So 40 plus 8 gives me 48. I have a total of 55 residents. So I still have 7 residents that I have to distribute. So I can distribute in the way of 0, 7 or 7 and 0, right? A can be 7, D can be 0, or A can be 0, D can be 7. So again, A can be 0, A can also not be 0. So I can eliminate beta. Now let's combine the two statements. Now if I combine the two statements, I have X, Y, and I also have Z to be 40. I have this region plus this region to be 8. And I also have the overall intersection to be 2. So if X plus Y plus Z is 40, 40 plus 2 is 42, 42 plus 8 gives me 50. Now remember, I still have 2 regions to work with. I still have 5 people to work with because X plus Y plus Z plus 2 plus 8 is 50. So I can distribute the 5 people as 5 and 0 or 0 and 5. So again, this region A can have some value, need not also have some value. So the answer here has to be echo. So you never make any assumptions, right? You only hold on to definite pieces of information in any data sufficiency question, right? So the big assumption for those who gave child to be the answer is you assume that the outer region is going to be 0. This is a very, very common trap, especially with Venn diagrams. Please don't make that assumption of taking the outer region to be 0. Okay with this, guys? All of y'all? Perfect. Okay, so these are the points that I wanted to make, put across right in front of you, so that you take care of these points when solving a data sufficiency, right? It always makes sense to tune your mind to look for these traps, all right? Because if you fall for one of them, then it's a big, big problem. Okay, so I have a couple of challenger questions to discuss, right? These would be good high-level questions, and it will test you on what you've held on to in the past, in the discussion in the past that has happened in the past 8 questions. Okay, so here's your first challenger question. Your time starts now. Just a clue so that you think in the right sense. Always don't jump into the statement, please. Always try to analyze the question first. Okay, get in the habit of doing that. All right, you can start typing your answers in the chat window. Guys, remember what we discussed? You only discard a statement only if you get a contradiction. Okay? Don't discard a statement unless you get that contradiction. Last call for answers. All right, so I see a lot of A's. I see 1D and I see 1E, right? So let's look at the question first, okay? For those who got alpha, I missed out on one important aspect. I would definitely want to know how you discarded the second statement. For those who got delta, that's a very, very, very good attempt because that's the right answer. Okay, and this is a very good question to get right because it is hard, right? Now let's look at the question. If n is a positive integer, what is the last digit of 1 factorial plus 2 factorial plus 3 factorial till n factorial? Remember, I need the last digit, right? Now think about it, right? If I put n is equal to 1, what I'm going to get is 1 factorial. So the last digit will always be 1 when n is equal to 1. If I put n is equal to 2, then I'm going to get 1 factorial plus 2 factorial. Now 1 factorial plus 1 factorial is 1, 2 factorial is 2, 1 plus 2 gives me 3. If I put n is equal to 3, I'm going to get 1 factorial plus 2 factorial plus 3 factorial. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. So I'm going to get 6 plus 2, 8. 8 plus 1 gives me 9. So I know the unit digit is going to be 9. If I put n is equal to 4, I'm going to get 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. That's 1 plus 2 plus 6. And 4 factorial is going to be 4 3s are 12. 12 2s are 24. 24 plus 6 is 30. 30 plus 3 gives me 33. So the unit digit has to be 3. Now, whenever I put n is equal to 5, right, that's going to be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial gives you 33. And remember, the unit digit of 5 factorial or any factorial beyond 5 factorial will always be 0. Because whenever you have 5 factorial, it's going to be 5 multiplied by 2, which gives me a 0 in the end. So I know any value of n that I take, which is going to be 5 or greater, or better, any value of n that I take, which is going to be greater than or equal to 4, will always give me a unit digit of 3. Yes? So all I have to do is check which one of these 4 possibilities would the statements give me. Now let's look at the first statement. The first statement tells me n is divisible by 4. Now if n is divisible by 4, n can be 4, n can be 8, n can be 12, and so on. 4 factorial if I take to be n, I'm going to get the unit digit to be 3. 8 factorial if I take, the unit digit will still be 3. 12 factorial if I take, the unit digit will still be 3. So the first statement clearly is sufficient, and most of y'all figured this out. Now the second statement is where you have to be a little more careful. N square plus 1 divided by 5 is an odd integer. Now think about this, right? If n square plus 1 divided by 5 is an odd integer, remember you have to satisfy the statement first and then, answer the main question. So what can be the first value of n that I can substitute? Anybody? If n square plus 1 divided by 5 has to be odd, what can be the first value of n that I can substitute? Perfect. N can be 2. Now think logically. What is the unit digit when n is equal to 2? 1 factorial plus 2 factorial. So the last digit has to be 3. Now what other value can you put for n? N is equal to 7. Perfect. Before that, any other value less than 7 that I can put in? Before that, any other value less than 7 that I can put in? Somebody told me n is equal to 2. Absolutely agree. Can I put n is equal to 3? Perfect. If I put n is equal to 3, would it satisfy the statement? And this is where I think most of you all have gone wrong. How many of you all put n is equal to 3? If you all put n is equal to 3, you're going to get 3 square, which is 9. 9 plus 1 is 10. 10 divided by 5 is even. Remember, you always have to satisfy the statement first. N is equal to 3 goes against the statement. So I'm not going to be able to use n is equal to 3. And this is why most of you all have discarded the second statement. Because you didn't bother about making sure the statement is satisfied. You just directly went and answered the main question. The next logical value of n would be 7. Can I use n is equal to 7, guys? Is it possible for me to use n is equal to 7 again? Anybody? And this is for those who made the mistake of 3. Can I use n is equal to 7? Think about it. 7 square is 49. 49 plus 1 is 50. 50 by 5 is 10. Is 10 an odd number or even number? Perfect. So I can't use n is equal to 7. So somebody said n is equal to 8. 8 is absolutely fine. So you'll realize that the values I can only use is n is equal to 2 and n is equal to 8, right? I'm only going to check for these two because if I know n is equal to 8, the unit digit will always be 3. And by breaking down the question stem, I've realized that any value that I take greater than or equal to 4 will always give me a unit digit 3. So the only thing I had to test for in the second statement was n is equal to 2. N is equal to 2 also gave me the unit digit 3. And any value of n greater than or equal to 4 will always give me a unit digit 3. So I'm not able to disprove the second statement, right? It's still giving me one definite answer that the unit digit is always going to be 3. So both statements individually are sufficient. Okay with this, guys? You have to be a little careful, right? You have to always make sure you satisfy the question stem, satisfy the statement first before you answer the main question. Okay, because statements given to you are always cardinal truths. Yes, you can put n is equal to 4 also, Sanjana, absolutely fine. 4 square, think about it, right? You can put n is equal to 4, but will it satisfy the second statement? That's what you have to test for. If I put n is equal to 4, 4 square is 16. 16 plus 1 is 17, right? 17 by 5 does not give me an odd number. So even though I can use n is equal to 4, it doesn't satisfy the statement. So I can't use it to answer the main question. Okay with this? All of y'all? On harder questions, you'll have to juggle between all concepts, right? Perfect. Can you move on to the last question of the day? All of y'all? Okay, so let's skip this. Okay, let's actually work with that. We're running short of time, so I'm cutting down one question. I want all of you all to try this question, please. Your 2 minutes start now. Okay, guys, you can start typing your answer in the chat window. It's not a very tough one. I'm not denying, Shikhar, it's not a tough one, right? Yes, definitely. Considering the last one, this is not as tough as the last. The reason why I've put this is because I want you to consolidate what we've discussed throughout, okay? The purpose is not I want to give you only a hard questions. Is the purpose is if you've taken back what I've told you before. You'll see that if you're looking in the chat window, right, you'll see that people are still giving Charlie to be an answer, right? Because they have not taken back what I told you in the beginning. You can only discard a statement only if you get a contradiction, right? You don't discard just because there are two variables. Yes, C is the obvious, right? So this is a classic C trap, isn't it? Yes. Okay. So most of you all have taken back what I've said. It's a pretty easy one compared to the last. So the question says Marta bought several pencils. If each pencil was either a 23-cent pencil or a 21-cent pencil, how many 23-cent pencils did Marta buy? So I know that, let me keep the 23-cent number of 23-cent pencils to be X and the 21-cent pencils to be Y. So we have 23X plus 21Y is going to be equal to the total amount that she pays for all the pencils. And remember, I need to find out the value of X. I'm breaking this question down. So the first statement tells me Marta bought a total of 6 pencils. So I've been given that X plus Y is equal to 6. Now I'll have to check whether this statement is sufficient to answer the main question. If X plus Y is equal to 6, I know I can use multiple possibilities for X and Y. Insufficient, clearly. Second statement tells you the total value of the pencils Marta bought was 130 cents. That's 23X plus 21Y is equal to 130. Now, for those of you all who discarded this statement just by saying it's one equation with two variables, you again went against the process of how to solve a data sufficiency. You didn't look at a contradiction. You just said that it's insufficient because it has two variables. You can only discard a statement if you get a contradiction. I'm repeating this. So whenever you see an equation like this, right, the better thing to do is to always plug in values for X and Y which satisfy the equation and then try to disprove, right? So can you tell me, guys, for all of you all looking at this equation, and for those of you all who gave me B, why did you all pick B? I can have multiple possibilities for X and Y. Is it possible for me to have that? I can't, remember, since I'm dealing with pencils, I can't have fractional values for X and Y. I also can't have negative values for X and Y, right? So I can only have positive values for X and Y or 0, isn't it? Exactly. If you plug in values for X and Y here, you'll realize that the only combination of X and Y that is going to satisfy this statement. Perfect. So let me tell you how do you disprove that, Shikhar, okay? So most of you are saying that the only possibility of satisfying the statement is if you put two values, X is equal to 4 and Y is equal to 2, right? So let's see if it works. So 23 into 4 is 4 3s are 12, 4 2s are 8, plus 1 9. 21 into 2 is 2 1s are 2, 2 2s are 4. Does this give you 130? Is it possible for me to put X is equal to 4 and Y is equal to 2? Any of y'all? What would be the two solutions for X and Y in this equation? What would be the two solutions of X and Y which gives you perfect 2 and 4? So 23 into 2 plus 21 into 4. 23 into 2 is 46. 21 into 4 is 84. This adds up to 130. Yes? Now, obviously the question would be how long do I go on plugging in, right? And how long do I go on checking? So this is where you have to be smart with how you plug in values, okay? And whenever you work with such equations, remember the unit digit is always going to be your friend. So if I need the unit digit to be 0 here, there are multiple possibilities for me to work with. I can have 23x to give me a 0 and 21y also to give me a 0. Now, the only way I can get two zeros here as the unit digit to give me an overall unit digit 0 is if I put x is 10 and y is 10, which is ruled out because I can't have the values of x and y to multiply 23 and 21 and give me something greater than 130. The other combination I can have is 9 and 1 or 1 and 9. That is also ruled out because 23 into 3 itself is going to give me 3 3s are 9, 69, and 21 into 1 is 21, which doesn't add up to 130. If I take 1 and 9, then the only way I can get 9 as the unit digit here is if I take 21 into 9, which again crosses the 130. Same holds good with 2 and 8. The only way I can get 8 here is if 21 is multiplied by 8. Not possible. And the only way I get 8 on 23x if I do 23 into 6, which again crosses 130. So out goes 8 and 2. Now if I need 7 and 3, the only way I can get 7 here is if x is 9. That's also not possible. The only way I can get 7 here is if y is 7. Again, not possible. So now I'm going to check for 4 and 6. Again, you'll realize the only way I can get 6 is multiply by 6, which gives me all the answers to be way more than 130. Unless I come down to a combination of, anybody, 6 and 4. When I take 6 and 4, 23 into what gives you a 6 as the unit digit? 23 into 2, that's the lowest value. And 21 into what gives you a unit digit of 4? 21 into 4. So 23 into 2 gives you the 46, 21 into 4 gives you 84, which gives you the 130. Right? So I have eliminated all possibilities and only stuck to one possibility which satisfies the statement. Right? So this is the only possible equation that satisfies the statement, beta. Right? You'll have to make sure that you always put in values and get to an answer. Okay? Everybody? Yes, if I put x as 0, y can have a max value of 5, right? So it's still, think about it, no? 5 ones are 5, 5 twos are 10, right? I can't have 6, so it still doesn't add up to 130, isn't it? Perfect, perfect, perfect. That's easy. That's a good way to work because you're finding out the max and min values for x and y. So if the max value is 5, you know that you don't need to test for 9, 1, 8, 2, and 7, 3. Directly you can check for 4 and 6. Why can't you take 0? Why can't you take 0? I mean, what is wrong in saying that you can have a condition of 0? Nowhere have they told you, right, that you have to buy either a 23 cent or a 21 cent, right? It's not mentioned there, isn't it? So you can't make that assumption. You still have to test for 0, isn't it? So what is there? I mean, I can buy 0, 23 cent, right? Nowhere have they told me that she has to buy, no? Okay with this, guys? So the point I'm making here is you don't discard a statement just because it has two variables, right? You work your way through and try to get that contradiction. Yes, it has to be mentioned in the stem or with the statement that you're working with, okay? Then only you can take that into consideration, right? You can't make any assumptions, guys, okay? You have to hold on to definite pieces of information. Perfect. So these are the points that I wanted to put across, okay? Especially with data sufficiency. Some of the other data sufficiency strategies would be more specific to particular concepts. So maybe that's a discussion that we can have at a later date once most of you all have gone through the videos of the online course, all right? Or have gone through the classroom sessions. Because it's more concept specific, I'll have to discuss certain concepts with you with data sufficiency. So we'll discuss that maybe in another session in 2 weeks time. All right. Okay, guys, so we'll wrap the session now. Any final doubts? Last call for doubts. Sanjana, you can actually send an email to prep@crackverbal, okay? And I can send the slides to you in a PDF format, okay? Prep@crackverbal. Any last doubts, guys? Last call for doubts before we wrap up. All right, thank you, Ghanshyam. All right. Okay, guys, so I guess I have no questions. just one small announcement before you log out, guys. If you're new to Crack Verbal, you haven't yet seen the online videos that we have. Quickly go to the GMAT online website that we have, and you can have a look at some data sufficiency strategies. So today we spoke about the DS traps. On the website you have a good set of around 4 hours of video which deals with some problem solving strategies and data sufficiency strategies. Okay, it's open to view for everybody. Just make sure you go on the website and have a look at it. It'll help you supplement your preparation on data sufficiency. All right, so good night guys, take care. I'm going to see you in 2 weeks time.